In section 1.4, we are still solving equations. So our goal is still going to be to get x or whatever variable it is by itself. This time we are just going to start involving absolute value. For our warm-ups, we are asked for what the absolute value of -8 is. What is it? 8. Remember, absolute value is always positive. What could give us an absolute value of 6? 6 or -6. Either one of those would give us an absolute value of 6. An absolute value equation is an equation that contains an absolute value expression. You should not need to write down the recall. The recall just states that the absolute value tells you the distance a number is from 0 on a number line. Okay, we've looked at a couple of these in the warm-ups. We could write down a couple more examples. What's the absolute value of 5? Careful.
-5.
Absolute value is always positive. So some people were correct in saying 5. Some people said both positive and -5. That's not the case. Absolute value is going to come out to be positive. Always. What about the absolute value of -7? 7. What about the absolute value of 0? 0. It's up to you how much of a refresher you need. So we are going to get into our examples, and we will talk about how these get solved. Our general steps for this are going to be to get the bars alone, the absolute value bars. And then our second step is going to be to split into 2 equations without bars. W/O means without. If you want to write out the whole word, that's fine. Get the bars alone, then split into 2 equations without bars. So our first step is to get the bars alone. Is there anything outside of my bars right next to it? Anything out in front? Anything right behind it except for the equal sign? No, so the bars are alone. That's always going to be our first step. These first couple problems, they already did that for you. Once the bars are alone, we're going to split it into 2 equations. This is the big important part. One of the equations looks exactly the same, but without bars. So x equals 4. The other equation, the part that had the bars, again, just drops the bars. But instead of a positive 4, we are now going to make it a -4. And again, like we did in the warm-ups, you guys gave me those answers anyway. When it was a question mark in there, you guys told me that to get an absolute value of 6, we had to have 6 or -6. So here it should make sense that to get an absolute value that equals 4, our options would be +4 and -4. Now this will get a little more complicated when there's more going on inside of the bars, but these first couple are pretty easy. So let's do it again on number 2. The bars are alone, so we split it up. One of the equations is exactly the same, just without bars. So what would that look like? X equals 12. The other one is going to be very similar, except for what's going to change. The what will be negative? The 12 will be negative. Notice that the x part stayed the same, exactly the same both times. It just dropped the bars. So on both of these, we got 2 answers. We would need both of the answers to get all of our points. It's not one or the other. It has to be both. All right, we've got a couple more examples. Number 3, the absolute value of x is equal to 100. Are the bars alone?
Yes.
Yep, there's nothing going on right around outside of them except for the equal sign. So we're ready to split it up. What will one of my equations be? Good. X equals 100. The other one?
X equals negative 100.
Very good. X equals negative 100. Number 4 is a little bit tricky. Can anybody tell me why number 4 would be different?
Because there's a negative 10.
There's a negative 10 there. So we have an absolute value equal to a negative. Is that possible?
No.
No. So there is
It's,
no solution.
okay.
So there is no solution. If you have the bars alone and it equals a negative, there's no solution. That's all you have to write. Questions about 3 or 4? Okay. I think these next ones take us up a notch. They do. Our steps are generally going to be the same, though. We're going to make sure the bars are alone, and we're going to split it into 2 problems. The difference on these ones is that there's more going on inside of the bars now. It's not just the variable. So on number 5, bars are alone. We're ready to split it up. What will one of my equations be?
Y equals, I don't know. Y minus 2 equals 4.
Very good. The first one is still just dropping the bars. Everything stays the same.
And then it'll be y minus 2 equals negative 4.
Very good. The other one is y minus 2 equals a negative 4.
Okay. And that's the answer.
That's not the answer. Do we have y alone?
No.
No. So what do we need to do now? Liam?
Add 4 or add 4.
Add 2 to both sides on both of them. So we have 2 separate equations. We have to solve both of them. This is where I want you to make sure you're being very careful and not rushing. So on the first one, when we add 2 to both sides, what do we get for y?
Y equals 6.
6. Good. That does not mean that the other answer is a negative 6. In fact, it is definitely not negative 6, because on our other one, when we add 2 to both sides, we have negative 4 plus 2, which is
2 or negative 2.
negative 2. So on some of the problems, you'll get plus and minus the same exact number, but on other ones, you will not. So make sure you're being careful about it. Questions about number 5?
No.
I do expect to see the plus 2 on both equations.
So that's if the y is not alone.
Right. If the y is not alone, you got to make it be alone. All right, on number 6, let's set up our 2 equations.
R plus 4 equals 1.
R plus 4 equals 1, and
R plus 4 equals negative 1.
very good. Is R all the way alone now?
No.
No, we still need to solve for it. So what will I do? Subtract 4 on both sides of both equations. So on my first equation, what do I get for R?
R equals
Close. Liam?
Negative 3.
Negative 3. Again, on the other one, we're still subtracting 4 on both sides, and we get r equals, what is it?
-5.
-5. These ones really follow the same steps.
So we'll do 7 minus x equals 4. And we'll do 7 minus x equals negative.
Yep,
4.
we'll set up our equations the same way. These equations will just be a little bit trickier to solve. So like Z said, we're going to have 7 minus x equals 4. 7 minus x equals -4. Notice that the only sign that changed was on the 4. We didn't change any of the signs from inside of the bars. Now the tricky part is solving these. What do I need to do first?
Do you do minus 7 on both sides?
Very good. We need to subtract the 7 first. If you didn't do that first, it's not going to come out right. We also need to be careful about what's left. So when I subtract 7, what do I still have on the left side? A negative x. Good. And 4 minus 7 gives me -3. But I didn't want a negative x. I want just x. So what needs to happen, Liam?
So you add 1.
Nope, not add, Lydia.
Minus 3.
Very good. Divide both sides by a -1. That's how we get it to switch signs. A negative divided by a negative makes our x positive. That's what we wanted. Same thing happens to the 3. Negative divided by negative is a positive. Are we done?
Mm-hmm.
No, what do we still need to do?
Whoa.
That whole other equation.
Dang.
So what do we need to do to both sides now? Subtract 7. The steps don't change, but the numbers will. Negative x equals what? -11. To get x to be positive, we need to divide off that -1. X equals +11. Go ahead and try number 8 on your own if you have not already done so, and we will talk about it in just a moment. All right, somebody I haven't heard from yet. Tell me what equations you set up. No, I've heard from you. Z? Hunter.
5 minus x equals 11.
What's the other one?
5 minus x equals -11.
Very good. We have 2 equations set up. We need to solve them. First step to solve would be
Minus 5.
subtract 5 on both sides. So that leaves me with -x equals
6.
6. To get x all alone, I need to divide by -1. And x equals -6. Good. It's okay for your answer to be a negative. The only thing that isn't okay is if in the very beginning the bars equal a negative. That's the only time a negative is bad. All right, on the other one, we solve it with the same steps. We're just going to get a different number. This time -x equals... What is it, Dominic?
This is -16.
Good, -16. We gotta watch our signs. And then what do we need to do?
Divide.
Divide off that -1 so that we end up with x equals
16.
+16.
Wait, Miss Barrett.
Z.
That one over there, 10. Is it like the same one? Because I really don't be getting it.
This is the absolute value of 5b equals 10.
Mm-hmm.
This one is the absolute value of x divided by 7 equals 2.
Yeah.
All right. Let's get these done. When I split it up, one of my equations will be what?
5b equals 10, and then 5b equals negative 10.
And then to solve both of these, I need to do what?
Subtract
Nope.
40.
Divide. To undo multiplication, we use division. So we are dividing both sides by
5.
5.
Oh,
That gives me b equals
b equals 2.
2. And on the other one, when I divide by 5, I get b equals
Negative 2.
-2. On number 10, bars are alone, so I split it up. What's one equation?
I don't know.
Liam? Oh. Good. X divided by 7 equals 2. And the other one?
Negative x divided by 7 equals 2.
Careful. Sign doesn't interchange on the x. What's it going to change on? The 2. So the x over 7 stays the same, and that 2 that was not ever in the bars changes signs.
I don't know.
How do we solve this one?
Do minus 2.
Not minus. We got to
Divide.
multiply. To undo division, we use multiplication. So we get x. Ooh, sorry. All right. We said we have to do this by multiplying. So we get x equals 2 times 7.
14.
The other one we would get
Negative 2.
when we multiply, what do we get? Good, -14.